Hi everyone, so now we are going to implement the quicksort sorting algorithm. So let's see how we can write the code. So the first thing I'm going to do, I'm going to take a vector and I'm going to sort it. So I have to take input this vector by reference. If you're using C++, then vectors are by default passed by value like all other STL containers, okay? So I have two methods. One is a partition method that is going to help me to divide the array, and this quicksort method is the method where we are going to write the algorithm. So since it is a recursive algorithm, we will have a base case and a recursive case. So in the base case, we can say if you have 0 or one element, we can simply say return. We don't need to sort that part of the array. So if start is greater than end, no elements, and if start is equal to end, then we have one element in the array. So in the recursive case, we can simply say we will first partition the array about the pivot element. So we'll make a call to the partition method and we will give start and the end index. Okay, so this partition method will do one thing. It will basically try to divide the array in two parts. Let's say this element is the pivot element, okay, and it tries to place the pivot elements in its correct position. So let's say the correct position of the pivot element is P, and we have this array in which all the elements are less than pivot, okay, but they are not sorted. So it is from 0 to, or from S to P minus 1, and we have this part of the array from P plus 1 till end. This has all the elements which are greater than pivot, okay. So let's assume that this P index is returned by this partition method, okay. So what we will do now, so suppose this partition method is there, then we need to make a call on the left part, that is quicksort on the array from S till P minus 1, and we need to make a call on quicksort on the right part from P plus 1 till the end of the array, and that's it, okay. So the main method that we are going to write is now the partition function. So let's see how we can write the partition function. So as I discussed, what we will do, we will take two variables, okay, and let's say we have I, that is S minus 1, and we also have a pivot, that is array of E, and we have a J, okay. So for int J goes from start till less than pivot, okay. So J less than in E J plus plus. We are trying to iterate over all the elements of the array, and if we get a current element which is less than the pivot, then we need to do some operations. So let's see. So if array of J is less than pivot, then what we need to do, we need to do I plus plus, and we need to say swap array of I and array of J. So I will just tell you again what we have done here. And finally, once you are out of the loop, you need to bring pivot element to its correct index. So the correct index is I plus 1 for the pivot element, and the pivot element is placed at array of E. So we can say return I plus 1. Okay, so let us just go through the partition function once more. So let us say we have these elements 10, 5, 2, 0, 7, 6 and 4. So this element is a pivot element, okay. So what you can do, you start by iterating from left to right. So J is at this index, I is at this index, I is at minus 1, right, in the beginning. So we say okay, J goes from start till E minus 1. We say okay, if AJ is less than pivot, 10 is not less than pivot, we just go to the next index. 5 is not less than the pivot, we go to the next index. 2 is less than pivot, so what we do I plus plus. So we do I plus plus, I goes here. So I comes to first index, and we say okay, let us swap. So we do the swapping like this. We say okay, 2, 5 and 10. J is always moving, okay. So J is now at 0 and I is here. So what we say, 0 is still smaller than the pivot element, that is 4. So what we do, we say okay, let us do the swapping with I plus 1. So I goes to the next index, so we have 2 followed by 0, and we have 10 and we have 5. So till now we have processed these many elements. So we go to 7. 7 is bigger, we don't do anything, we do j plus plus. We go to 6, 6 is bigger, we don't do anything, and j stops here, and I basically stops here after end of one iteration, right? So now what happens? So finally we are out of this for loop, and we say okay, swap array of I plus 1. So array of I plus 1 is 10 with the pivot element, that is 4. We have 2 0 and 4, and we have 5 7 6 and 10, and you can see this is the correct index of 4, and we call this index as p when we make this function call. Okay, and for the remaining part we make a recursive quicksort call on this part and a recursive quicksort call on this part, and this is how our entire array gets sorted. So we'll get 0 2 from here, and after this entire array has been sorted, we will get 5 6 7 and 10, and 4 you can see is already in its correct place. So this is how the partition method works. Now let us build our code and try to run it. So we have quicksort, and we see that this is the output that we are getting: 0 2 4 5 6 7 and 10. So I hope this is clear now, and that's all for this video. Thank you.